Hello students, I am Vandana Soni with another interesting and learning episode of B.Pharma on the important unit of general consideration and application of drug delivery systems. Let's start our episode while taking a look at what we are going to learn today. With module 1, we learn about the bioadhesive and mucoadhesive drug delivery. In module 2, we learn about the factor affecting mucoadhesion. In module 3, nanopulmonary drug delivery, the whole chapter divided into 2 episodes. In first episode, we learn about the bioadhesive mucoadhesive drug delivery system and their factor affecting, followed by nanopulmonary drug delivery system. Module 1, that is bioadhesive and mucoadhesive drug delivery. The term bioadhesion defined as the adhesion between the two materials where at least one of the materials is of biological origin. In the case of bioadhesive drug delivery system, bioadhesion refers to the adhesion between the excipients and biological tissue. When adhesion is restricted to mucous layer lining of the mucosal surface layer, it is known as mucoadhesion. For the purpose of drug delivery, the term bioadhesion is defined as the ability of the drug carrier system adheres to the biological tissue for extended period of time. This leads to an increased drug concentration gradient at the absorption site and therefore improves the bioavailability of delivered drug. Bioadhesion dosage forms have also been used to target local disorder at the mucosal surface. The mucosal surface means the mucous ulcer, etc. to reduce the overall required and minimize undesirable side effect of drug. Advantages of the bioadhesion and mucoadhesive drug delivery system. It provides a prolonged residential time at the site of absorption or action. Second, a localization of drug delivery system at the given target site. Increase the drug concentration gradient due to the contact of drug with mucosal surface. Possible to bypass first pass effect and also avoidance of pre-systemic elimination within gastrointestinal tract, that is GIT. Inclusion of penetration enhancers such as sodium glycolate, sodium taurocholate and protease inhibitors in dosage form may result in better absorption of peptides and proteins. Now come to the another important aspect, that is mechanism of bioadhesion. There are 3 steps are involved in formulation of bioadhesive bonds with mucous membrane. First one is wetting and swelling of polymers to permit intimate contact with the biological tissue. Second one, interpenetration of bioadhesive polymer chain and entanglement of polymer and mucin chains. And third one, formation of weak chemical bonds between the entanglement chain. So, there are 2 basic steps required for mucoadhesion. First one is contact stage. An intimate contact is formed between the mucoadhesive and mucous membrane. Second step is consolidation stage. In this stage, the mucoadhesive material are activated by the presence of moisture and moisture plasticizes the system, allowing the mucoadhesive molecules to break free and to link up by weak van der Waals and hydrogen bonds. There are various theories available for the bioadhesions. Some of the theories are discussed as follow. First one is electronic theory. In electronic theory, electron transfers occur upon contact of an adhesive polymer with a mucous glycoprotein due to difference in their electronic structure. This results in formation of electrical double layer at the interfaces. Second theory is adsorption theory. According to this theory, addition is the result of various surface interaction, that is formation of primary and secondary bonding between the adhesive polymer and mucous substrate. Third one is weighting theory. The weighting theory is predominantly applicable to the liquid bioadhesive systems which having a affinity to the surface in order to spread over it. This affinity depends on the contact angle. Therefore, for greater affinity, the contact angle should be equal or close to 0 to provide adequate spreadability. Next, another theory, that is fracture theory. This is most used theory for the mechanical measurement of mucoadhesion. It analyzes the force required to separate two surfaces after adhesion is established. Then diffusion theory. Diffusion theory describes the interpenetration of both polymer and mucin chains to a sufficient depth to create a semi-permeable adhesive bond. So, this is about the bioadhesion and mucoadhesion and different theories. Now, come to the factor affecting mucoadhesions. There are several factors. First, polymer related factor. Under the polymer related factor, the first effect of the molecular weight. The mucoadhesion strength of the polymer increases with increasing the molecular weight of polymer. Mucoadhesion of polymer should have more than 1 lakh molecular weight. Second one is concentration of active polymer. In general, the more concentrated polymer would result in a longer penetrating chain length and better adhesion. Third important factor is degree of hydration. When the degree of hydration is high, adhesiveness is lost, probably due to the formation of slippery, non-adhesive mucilage in such environment. Then charges on polymer. Mucous surface is negatively charged, so positive charged polymers might facilitate the mucoadhesion process. Next is flexibility of polymer chain. Higher the flexibility of polymer favors greater diffusion into the mucous network. Now, another important factor, that is presence of functional group. The immobilization of thiol group present in chitosan and polyacrylic acid on microparticle improves mucoadhesion property, ultimately leads permeation enhancement. Then hydration. Hydration is required for a mucoadhesive polymer to expand and create a proper macromolecular mass of sufficient size and also to induce mobility in the polymer chain in order to enhance interpenetration process between the polymer and mucin. Next important factor, that is related to the environment. So, first factor is pH. pH influences the charge on the surface of both mucus and the polymer. For example, mucoadhesion of polymer, that is polyacrylic acid, is favored when the majority of the carboxylate group are in unionized form, which occur at pH below the pKa value. Applied strength. Second one is applied strength. The adhesion strength increases with the applied strength or with the duration of application up to an optimum level. Third one is initial contact time. The mucoadhesion strength increases as the initial contact time increases. Then physiological factors. Physiological factor includes mucin turnover. The mucin turnover is expected to limit the residence time of mucoadhesive doses form on the mucus layer. Then second one physiological factor is disease states. The physiological property of the mucus are known to be changed during the disease condition such as common cold, gastric ulcer, etc. Potential site of bioadhesive drug delivery. The mucus layer line system of regions of the body includes GIT tract, urogenital tract, airways, ear, nose, eyes, etc. Some of the examples for site of mucoadhesive drug delivery system as follows. They are buccal drug delivery system, sublingual drug delivery system, oral drug delivery system, nasal drug delivery system, ocular drug delivery system, vaginal drug delivery system, rectal drug delivery system. Now come to the evaluation of bioadhesive drug delivery system. There are various systems are available. First one, in vitro and ex vivo method. First method, that is based on the measurement of tensile strength. Second method, that is based on the measurement of shear stress. Another in vitro methods like addition weight method, fluorescent probe method, flow channel method, falling liquid film method, colloidal gold staining method, mechanical spectrophotic method, thumb test, viscometric test are methods. Addition number, electrical conductance. In vivo methods includes use of radioisotopes or gamma scintigraphy. Now come to the module 3. It is totally devoted to the nanopulmonary drug delivery system. Pulmonary drug delivery is a technological in which medicines are inhaled through the lungs and enters the bloodstream through the alveolar epithelium. It provides a non-invasive alternative methods to subcutaneous and intravenous injection. Pulmonary drug delivery system possesses many advantages including non-invasive route of administration, extensive surface area of alveoli for enhanced absorption of the drug, low metabolic activity, control environment for systemic absorption and avoids forced bypass metabolism, leading to great therapeutic efficacy without increasing toxicity. Pulmonary drug delivery is the preferred route of administration of aerosolized drug in the treatment of respiratory diseases include asthma and cystic fibrosis, infection diseases, in particular tuberculosis, and in some non-respiratory diseases such as type 1 diabetes. There are various advantages of pulmonary drug delivery system. It includes inhaled drug delivery system provides targeted drug delivery to the organ, that is lungs. Pulmonary drug delivery having very negligible side effect because rest of the body is not exposed to drug. Onset of action is very quick with pulmonary drug delivery system. Degradation of drug by liver is avoided in such cases. But there are certain limitations and challenges are there for pulmonary drug delivery system. This includes the short half-life and low drug bioavailability of inhaled drug are the main limitation associated with the current inhalation therapy. It is due to pulmonary clearance including mucociliary clearance and alveolar macrophages. Second one, it may be due to enzymatic degradation. Third one, due to rapid systemic absorption. In case of pulmonary drug delivery system, it is very difficult to control the pharmacokinetics of inhaled therapeutics beyond a few hours. Therefore, development of an appropriate drug loaded vehicle system with adequate aerodynamic characteristics that can be confer sustained release of drug once deposited in the lungs is considered one of the major challenge in inhalation therapy. The drug loaded carrier particle targeted to deep lung should be aerodynamically small enough to pass through the mouth, throat and conducted airways and reach to the deep lung, but not so small as they fall to deposit and are exhaled again. The most appropriate range of aerodynamic diameters of these particles to be respirable is around 0.5 to 5 micron. However, microparticles of this aerodynamic respirable size range are also of the size that is cleared most rapidly from the lung by alveolar macrophages. Now, there are various devices are available for pulmonary drug delivery system. Here we are discussing few. First one is polymeric nanoparticle. The main role of polymeric nanoparticles in drug delivery system are to carry the drug molecules, to protect drug from degradation and to control drug release. Due to biocompatibility, surface modification capability and sustained release property, polymeric nanoparticles are intensively studied using various important pulmonary drugs. Second delivery system is liposomal drug delivery system. Liposomes are one of the most extensively investigated system for controlled delivery of drugs to the lung. These vesicles can be prepared from compound indigenous to the lung, such as the components of lung surfactant, and these properties make liposome attractive candidate as drug delivery vehicle to the lung. Next category is solid lipid nanoparticles. The advantage of drug release from SLNs in lungs are control of the release profile, achievement of a prolonged release and having a faster in vivo degradation compared to the particles made from PLA or PLGA. In addition, solid lipid nanoparticles possess a higher tolerability in the lungs compared to the particles made from same polymeric material. Next device is dendrimers based nanoparticles. Dendrimers are polymers which have hyper branched structure with layered architecture, could potentially be used as a non-invasive delivery system for the treatment of thromboembolism disorder. Now come to the conclusion part. Advent of nanotechnology, new techniques, devices and their application in drug delivery was delivered a huge interest to scientists. These new techniques and devices are used to overcome the problem that are associated with the particular drug or delivery systems. For example, the viability of mucoadhesive drug delivery system enhances by utilizing the physicochemical characteristics of both the dosage form and the mucous lining. Similarly, pulmonary drug delivery with the novel devices also possesses many advantages, including non-invasive route of administration, low metabolic activity, control environment for systemic absorption and avoid first pass metabolism. Novel ocular drug delivery offers beneficial effects to the patient by minimizing the drug induced toxicities and protect from vision impairment, etc. The product approach is also used to overcome the various obstacles to drug formulation and targeting. With all these information, here we comes to end of today's lecture, application of following drug delivery system part 1. Do keep in mind what we discussed today. Time for you to self-study. I will be back with more lecture in this series application of following drug delivery system part 2. that deals with ocular drug delivery system and pro drug delivery system. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs. Till then, keep studying. Goodbye.